Today, we are going to cover section 9.7, applications of right triangles. So take the time to copy your title and your essential question. How can we use right triangle trigonometry to solve real-life problems? Go ahead and copy down those two triangles, and we'll start once you are ready. Go and pause it. So we know that if we have a right triangle, we have three sides, and we know one of them is the hypotenuse, and that is the one that's opposite the right angle. So therefore, this is your hypotenuse on both triangles. And we know that we have two sides. One of them will be your adjacent, and the other one will be your opposite side. It all depends on whether we are using this angle versus that angle. So if we are using this angle, if this is the angle that we are using, then we assume that we're standing here. So therefore, this is your opposite side. And this is your adjacent. But if we are using this angle up here, this will be your opposite side. And this is your adjacent. And that is because we are standing up here, we're using this angle. That is the opposite, that is your adjacent, and on both, that is your hypotenuse, which happens to be the longest side. Go ahead and paste your cutout and copy example number 1, and we'll start once you are ready. Go and pause it. So let theta be an acute angle of a right triangle. The 6 trigonometric functions of the angle theta are defined as follows, something that you guys learned last year and also in geometry. You know the sine is your opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you also, if you remember, you memorized it by so. So the sine is the opposite over hypotenuse. Cosine adjacent over hypotenuse. So ka. And tangent is your opposite over your adjacent. So katoa. And we know the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So let's go and solve the following triangle, ABC. They give you angle A to be 34 degrees in 10 minutes. And side C is 12.7 inches. So we are going to create a generic triangle. I'm just going to use a 3 by 5. We know that this is a right triangle, since that we are using right triangle trigonometry. So this only applies to triangles that have a right angle. And now we're going to label it. This is angle C. We're going to place A or B. I'm going to place A here and B down here. And now I can label this is 34 degrees in 10 minutes. Side C must be your hypotenuse, which is 12.7. And when they're asking you to solve the triangle, that means that we need to find all three angles in all three sides. And we are going to list them A, B, and C for the angles. Well, we know the C is 90 degrees, Angle A is 34 degrees in 10 minutes. Side A, side B, and side C. And the only one that we know is 12.7 inches. So therefore, we need to be able to find the remaining two sides in the angle. So which one do you want to find first? Correct. So the easiest one to find is this angle here. We know that all three angles equal to 90 degrees, or 180, or those two are equal to 90. So therefore, this should be 55 degrees, because that gives you 89. And what do I need to do to get to 60 minutes? 50 more. And now, this is 55 degrees in 50 minutes. You need to decide whether you want to find A or B first. So let's find A. So I'm going to use the angle that's given to me, so therefore I might be using this angle up here, angle A, and I'm going to be standing here. We are looking for side A, and they're giving us 12.7. So therefore, what should I use? Sine, cosine, or tangent? So that is the opposite, and this will be the hypotenuse. So opposite over hypotenuse will be sine. So the sine of 34 degrees in 10 minutes is equal to the opposite, which is A, over your hypotenuse, which is 12.7. And now I can solve for A. Solve for A, see what you get, and then we can compare our answers. So I'll multiply both sides by 12.7. It cancels. So therefore A is equal to 12.7, the sine of 34 degrees in 10 minutes. And we're going to type that into the calculator. So therefore 12.7 times the sine. Make sure that you guys have it on degrees. Right now I have it on radians, so I need to go into mode and change it to degrees. That'll be 34. I'm going to go under angle, select the first one, and 10. We'll go under angle and select the second one. And therefore that is A is approximately. Notice that this is an exact answer. And now we're going to round up to 2 decimal places. So it'll be 7.13. Now, some books will actually might tell you how many decimals you need. Some other books might tell you to use the significant figures. Because they have 3 digits in here, I need 3 digits as well. But for now, 2 decimal places is fine for me. Now, I need to find letter B. And I have a choice. I can use right triangle trigonometry, but since we have 2 sides, we can also use the Pythagorean theorem. So let's go and find B. So therefore, C squared is equal to A squared plus B squared. We have 12.7 squared. A will be 7.13 squared plus B squared. Now notice I'm going to keep this one here. And I can store it in a variable if I want to. Or I can just place it here and use it later. So 12.7 squared gives me 161.29. It's equal to, I'm going to use my previous answer, and I'm going to square it. So therefore, it'll be 50.87 plus B squared. I'm going to subtract it, and that gives me 161.29 minus 50.87. So therefore b squared is equal to 110.42. I'm going to take the square root of my answer. And that gives me b is approximately 10.51 or 10.5. Only that's 10.5 inches. So whenever you're trying to solve a triangle, just make sure that you are finding all three angles and all three sides. And if you can box in all the information, that'll be very helpful. So that is your answer. We found all three angles and all three sides. Example number 2. Go and paste your code, copy or paste your example number 2, and we'll start once you are ready. So when we are dealing with applications, many times they're going to refer to an angle of elevation or an angle of depression. Elevation, that means that we are going to elevate. So we're going to start from here and we're going to elevate. We're going to go up. Depression, we are coming down. Sometimes within a word problem, we might have to create your parallelogram or your rectangle or square to be able to find your angle of depression or your angle of elevation. And in that case, both of them will be congruent. So something to keep in mind. Example number 2. So take the time to read through it, highlight the key components, and we'll start once you are ready. So a server is standing 115 feet from the base of the Washington Monument. The server measures the angle of elevation to the top of the monument at 78.3 degrees. How tall is the Washington Monument? So it is essential that you draw a figure. So let's say this is the Washington Monument. And the server is standing 115 feet away from it, from the base. So therefore this is 115. The server measures the angle of elevation to the top. So the person standing here. The angle of elevation must be this one here. And that is 78.3 degrees. And we are dealing with a right triangle, so we can use SOHCAHTOA. So therefore, let's go and find x, the height. Find x and see what you get, and then we can compare our answers. So first, you need to decide, do I need to use sine, cosine, or tangent? So in this case, we're trying to find the height, which is x. That is your opposite. And we are given 115, which is your adjacent. So therefore, we have to use tangent. So the tangent of the angle, which is 78.3 degrees, is equal to the opposite, x over 115 feet. We can multiply both sides by 115, so therefore x is equal to 115, the tangent of 78.3 degrees. This is the exact answer. We are going to get an approximation, so therefore we are using a calculator. 115, make sure that you're on degrees, which I am, and the tangent of 78.3. And that gives me x is approximately, and they're not using any decimal places, so I'm just going to use 555. So the Washington Monument is approximately 155 feet, or 555 feet. Be careful. Notice that because we did not have minutes, I did not have to place the degrees symbol here. Only when you have degrees and minutes is when you have to use your angle degree and your minutes. In this case, you do not need it. Example number 3. You go and paste your triangle or copy it down, and we'll start once you are ready. And when they're trying to find the value of x, they are trying to find the from here to here is the value of x. So you're trying to find this side here. So notice that we have, how many triangles can you see here? We have 3 triangles, correct? We have this triangle on the right triangle on the right, and that is a right triangle as well. Then we have the right triangle on the left. And in addition, we have the larger triangle. Now, see if you can find x, and then we can compare our answers. Go and pause it. So if I notice for the yellow triangle, which is the part of the x, that we do not know any measurements there. If we use this triangle on the left, we can find either the base or the height, or we can use the larger triangle and we can either find that side or this side. But the problem with the larger triangle is that a 90-degree angle? Plus 62 plus 55, that is not a 90-degree angle. So therefore, we're not able to use the green triangle with SOHCAHTOA, because for SOHCAHTOA, you must have a right triangle. So therefore, we are going to use the orange triangle to find, I'm going to label as y. And once we have y, because they both have in common, we know that we can find x afterwards. So that'll be our game plan. Go and find y using the orange triangle. Then we're going to find x. Using the yellow triangle. So to find y, we are going to be using the angle that's given to us. So therefore, that'll be the opposite over hypotenuse. So we have to use sine. The sine of 62.3 degrees. So opposite y over hypotenuse, which is 32.5. We're going to multiply both sides. It gives us y is equal to 32.5, the sine of 62.3 degrees. That is an exact answer. We need to have an approximation, but notice that what I'm going to do, I'm going to keep this on my screen so I get a more accurate answer. So therefore, y is approximately 28.8 or 20.7. Only that's 28.8. Now I'm going to find x, and I'm going to be standing here. That'll be my opposite, which is 28.8, over my adjacent. So I need to use SOHCAHTOA, tangent. So the tangent of 55.2 degrees is equal to your opposite, which is 28.8, over your adjacent, which is x. And now I need to solve for x. So I'll multiply both sides by x. That cancels. So therefore we have x tangent of 55.2 degrees is equal to 28.8. I'm going to divide both sides by tangent of 55.2. So x equals 28.8 tangent of 55.2 degrees. Now when I divide this, if I need an exact answer, I will actually be placing 32.5 sine of 62.3 divided by the tangent of 55.2. In this case, we are going to just get an approximation. So I'm going to get my answer divided by the tangent of 55.2 degrees. And that gives us about 19.9, so it'll be 20, x is up 20 units. And we found the value of x. Example number 4. Find the value of x. Go and copy it down, paste it, and see if you can find the value of x, and then we can check our answers. So in this case, how many triangles do we have? We have 3 triangles, right? We have the yellow one here, the one on the left. We have the one on the right. The problem with the one on the right is that we are not able to use what we have so far to work with non-right triangles. So we cannot use SOHCAHTOA. So right now we cannot use the orange triangle because it's not a right triangle. But we have another right triangle here, which is the larger triangle. Correct? The yellow one and the green one are both right triangles. So what should I do? 7.5 is from here to here. Only the base of the yellow triangle. So correct. So we're going to find first, we are going to find the height, which is x. Once I find the height, then I can go and find the base of the larger triangle, and then I can find x. So let's call this y. Let's go and find y using the yellow triangle. Then I'm going to find x, or we're going to call it from here to here. I'm going to give it a different value. So I'm going to say this is z. So I'm going to find z using the green triangle. Or you can do it all at once and just find x. So therefore, to find y, I'm standing here. So that is my opposite and that is my adjacent. So I need to use sine, cosine, or tangent. Tangent. So the tangent of 56 degrees is equal to the opposite over your adjacent, which is 7.5. So therefore y is equal to 7.5 tangent of 56 degrees. So therefore y is approximately 11.12. And now I can use the green triangle to find z. So that'll be the opposite over adjacent again. So it'll be the tangent of 37 degrees is equal to the opposite, 11.12. I'm going to use the result from my calculator to give an exact answer, or a more exact answer, over z. I can multiply and then divide, so that would give me z is equal to 11.12 over the tangent of 37 degrees. Or you can go through the process that we did, just multiply both sides by z, then divide by tangent of 37. And now I'm just going to take my answer, and I can use my fraction bar, or I can just do division. And therefore my z is approximately 14.76. Notice I'm not using the 11.12, I'm using the answer, so I get more of an exact or more precise solution. So therefore, now we can find x, which is z is equal to 7.5 plus x, correct? So therefore 14.76, 7.5 plus x. Therefore x is equal to, I'm going to subtract 7.5, 7. And they don't have, they have one decimal place, one place as 3, it'll be miles. So now we're going to continue with more applications dealing with bearings. So take the time to paste your card or copy it down, and we'll start once you are ready. In surveying and navigation, directions can be given in terms of bearings. We have two types of bearings that we're going to cover. True bearings to a point is the angle measured in degrees in a clockwise from the north. So therefore, we are going to start from the north when we do true bearings, and we're always going to rotate towards the right. First, we're going to rotate 60 degrees. So whenever it's dealing with direction, with navigation or surveying, whether you're on a plane or land or air, you are going to go from the north towards the right. Now 60 degrees, I'm going to place my two dashes to evenly divide it. So it'll be 30, 60, 90. So 60 degrees will be in this direction. So therefore we're going to start here, and we are going to go towards the right. And most of the time this will be when you are doing from sea. So if you're in a boat, you're going to be doing true bearings. 220 degrees from the north towards the right. So this was the rotation from the north towards the right. Now 220, well, I know that this is 90 and this is 180. How much more to get to 220? 40 more. I know that my halfway mark is 45, and I'll go just a little bit less. So therefore this will be 220 degrees from the north. 120, this will be 90 plus how much more to get to 120? 30 more. I'll place my two dashes. So 30 more is this way. So therefore we're going to start from the origin and we're going to go towards that direction. Now we have conventional bearing. It tells you from where to start, the north or the south, and what direction to go towards. Now, all of you guys know this is never eat soggy waffles. Or you know the other one. So in this case, I need to start from the south and go towards the east 70 degrees. So I'm going to start from the south and I'll go towards the east. So south, and there'll be 70 degrees. So I know that's 30, 60, 90. So I'll be around here, just a little more than 60. So I'm going to start here and I'll go towards this direction. South, 30 west. We're going to start from the south and we're going to go towards the west, 30 degrees. So it'll be 30, 60. So it'll be in this direction here. North, 40 degrees east. we're going to start from the north and we're going to go towards the east 40 degrees. So I know it's 45, so just a little less than 45. And make sure that you give me the angle of rotation for these problems. So now let's go and start some of the word problems and some of the applications. Go ahead and read through it, or you can paste it or copy it down, and we'll start once you are ready. So radar stations A and B are located on an east-west line. So we're on a horizontal line with A west of B. So therefore, we have two stations, and A is west of B. And they are 3.7 kilometers, 3.70 kilometers apart. Station A detects a plane at sea, so it's going to detect a plane somewhere above on a bearing of 61 degrees. They don't give you a direction, so it's going to go from the north towards the right. Now, when doing this, it is important that you place an X and Y axis dash, Y-axis, and A-axis, then X-axis, from the point of rotation. So we're going to go from the north towards the right, 61. I'll place my two dashes, 30, 60, 90. So 61 will be around here. And you want to make sure that you get to a point. You can place it here or here, one of the corner points. You don't want to just make a random line, but you want to make sure that you get about around here will be fine, or here. Let's place it up here. And therefore, this is from the north towards the right is 61 degrees. Station B simultaneously detects the same plane, so therefore at point C, which is, this is point C, on a bearing of 331 degrees. So I'm going to place an X and Y axis at point B, and you want to make sure that you place your X and Y axis as a dashed line from the point of rotation. It'll be 331. I know that this is from the north towards the right. That is 90, 180, 270. How much more to get to 331? 61 degrees. So 30, 61. And I'm just going to force it to be to that point. So therefore, this is 331 degrees. Therefore, what is the measurement of this angle here? Well, I know that this is 270. To get to that point, it was 61 degrees more. And this is 61. Together will give you 90. So therefore, this has to be 29 degrees. And now we can find our missing side, or missing angle. This is 29. This is 61. That is 90. So therefore, this is a 90-degree angle. And we need to be able to find the distance from A to C. So I need to be able to find this distance here. So therefore, I'll be using, do you want to use angle A or angle B? You get the same answer. So let's go and use angle A, and we're going to use find X. So we're using this side and the base, or the hypotenuse. So therefore, if I'm standing here, this is my adjacent and this is my hypotenuse. So K, so we're going to use cosine. The cosine of 29 degrees is equal to the adjacent, which is X, over your hypotenuse, 3.7. So therefore, X is equal to 3.7 cosine of 29 degrees. That is an exact answer. I need an approximation. So 3.7 times the cosine of 29 degrees. So therefore x is approximately 3.20. And they're using two decimal places, so I use two decimal places and kilometers. The distance from A to C is 3.24 kilometers. So let's try a few other more challenging problems. Example number 6. Go ahead and paste it or copy it, and we'll start once you are ready. Go ahead and take the time to read through it. So a ship leaves port and sails on a bearing of north 47 degrees east for 3.5 hours. It then turns and sails on a bearing of south 43 degrees east for 4 more hours. If the ship's rate of speed is 22 knots, miles per hour, nautical miles per hour, find the distance that the ship is from the port. So therefore, I'm going to place my ship somewhere in the middle, so that I have space to navigate. So this is where we're going to start. And first we're going to do a bearing, so a rotation of 47 degrees from the north towards the east. So let me go and place my x and y axis. I'll place as dash, so for my rotation. You always want to be able to place your x and y axis. It is essential for you to be able to do it right, especially as we go into more challenging problems on the next chapter. So from the north towards the right, 47. So I know that this is 45, so I'll go just a little bit more, 47. So that's 45 will be 47 here. You want to force yourself to get to a corner grid. I'll place it here. So therefore, I'm going to label my angle. This is 47 degrees and 3.5 hours. Now they're going on a 22, so I'm going to multiply 3.5 times 22, because we know the distance, rate times time. Will be 77 miles. So therefore, this is 77 miles. Then it turns and sails on a bearing of south 43 degrees east from this point here. So therefore, I'm going to place a new x and y axis from the new location, because now you have navigated to this location and your turn will be based from here. So you want to make sure that you place your x and y axis for your new turn. And now it's going to be from the south towards the east. So never eat soggy waffles. So from the south towards the east will be 43 degrees. Well, I know this is 45, so 43 will be just a little bit less. I'm going to force myself to get to a grid. Now, be careful. It doesn't mean that you're going to end up here. You can, but this is for 4 hours, so this side has to be just a little longer. Let's say I made this one about 4, so I'll make this one about 5. So 5.5. So, but I am going to get to the grid. I'm forcing myself to get to the grid. And that's going to be essential for you to be able to solve this type of problems. And this is 4 hours. So it'll be 4 times 22. That gives you 88 miles. If the ship rate is 22 knots, find the distance the ship is from the port. So this is the port, and now the ship is over here. So we're going to label as X. Let me label my rotation, which is 43 degrees. So now I need to be able to find the angles in the triangle. So see if you can manage to do that. See if you can find at least one of the angles. Go and pause it. You got it? So this is 43, right? This is 47. If you notice that these two lines here, this line and this dash line, both of them are parallel lines, and this is your transversal. So therefore, that is 47. This must be 47 as well. Or if you want, you can see, this is a right triangle right here. This is 47. This is 90. Together has to be 90. So therefore, this one is 43. And this is a 90-degree angle. So therefore, this one must be 47. So 47 and 43, this is 90. So therefore, this is a right triangle. And remember that on this problem that we are working on, we are working with right triangles. So one of them should be 90 degrees. We can't find this angle here because I know that this is 43, but I don't know what this angle is. And I can't find that one either. So therefore, we have two sides in the angle in between. So therefore, I can find, well, I know that this is a right triangle, and I'm missing one side, so I can use Pythagorean theorem. So c squared is equal to a squared plus b squared. I'm looking for which side? A, B, or C? I'm looking for C. So c squared is equal to 77 squared plus 88 squared. C squared is equal to 77 squared. That's 5929 plus 88 squared. C squared is equal to 13,673. I'm going to take the square root of 13,673. So therefore, the plane is approximately 100 and you see no decimal places. I'm going to give them no decimal places. And the last example for today. Go and take the time to read it, see if you can make a sketch, and then we can compare our sketches. Go and pause it. So the bearing from A to C is south 52 degrees east. The bearing from A to B is north 84 degrees east. The bearing from B to C is south 38 degrees west. A plane is flying at 250 miles per hour. It takes 2.4 hours to go from A to B. So let's do the first bearing. Let's go and start with A. I'm going to place it somewhere in the middle. So I'll space on the left, up or down. Since we're doing a bearing, and the first bearing is south 52 degrees east, I need to place a x and y axis. From the south towards the east. From the south towards the east, 52. I know that's 45, so just a bit more. I want to make sure that I force myself to get to a grid, so I want to come over here. This is 52 degrees. And from A, that's where we started, to C. The bearing from A to B is north 84 degrees. From A, I'm going to do my bearing. I already have my X and Y axis. So towards the right, north 84. So that's close to here, right? That's 90. And I'm going to force myself to get to the grid. So I can go right over here. One of the things I have to be careful is that I don't want to get actually to this point. I want to make it, I want to go just a little longer. I want to go over here. And now I'm going to make my triangle. Or if you want to make it here, it's fine. And we'll be able to tell by from A to B, is 250 times 2.4. 600. This is 600. I need to be able to find the distance from A to C, so I'm going to need to find X. Let me place my rotation before I forget. This is 84 degrees north, 84 degrees east. So therefore, I need to be able to find some additional angles. Well, I can find the angle in between. This is 52 and that's 84. I know that all three will make 180. So 180 minus 84 minus 52. That's 44 degrees. But we have one more bearing to do. From south, from B to C, that will tell me whether it's, should I place it here or should I place it up there, is south 38 degrees west. So from B to C. I'm going to have to change my drawing if this is the case. Southwest is 38 degrees. Southwest. So that looks pretty good, right? 38 degrees. So let's assume that I have left, if I left over here, then I knew that that measurement will be wrong. Then I'll have to make it longer. In this case, I got lucky. So now that's 38, that's 44. What other measurements can we find? So one of the things that we need to start doing is I must start making these triangles here. As well, you know, that's a right angle. That's 52 plus what number will give me 90? That'll be 20 or 38. That's 38 degrees. This is 38 degrees, so therefore this is 52. I know that all three angles will be 180, so 180 minus 38 minus 52 give me 90. So therefore this is my 90-degree angle. And yeah, at this point we are working with right triangles, so we know that one of our angles will be 90. And now we can actually find the value of x. Because we have a right triangle, I can use SOHCAHTOA. So this will be 44 is my angle. So this will be my adjacent over my hypotenuse. So this is my adjacent. This is my hypotenuse. So my use. So cosine, correct. So find x. So the cosine of 44 degrees is your adjacent over your hypotenuse. So therefore x is equal to 600 cosine of 44 degrees. I can type that into the calculator. This is the exact answer. I need an approximation. So the distance, and they're not using any decimal places, so I'm just going to use 432. So the distance from A to C is 432 miles. So this will conclude the lesson for today. Have a great day, and I'll see you next time.